Hello everyone, welcome to your study guide lesson 5-6, Graphing Proportional Relationships. This lesson is found on page 109. When I look ahead in the lesson and I scan through it, I find that we're going to learn about how to identify proportional relationships from a graph and how to use a graph to find the constant of proportionality. So we're going to identify proportional relationships, okay, when they change at a constant rate, and how to graph these constant proportions, right? How we're going to graph them. For a quick review, we have to write an equivalent fraction for each fraction given below. So 3/4. Now, this is relevant, boys and girls, because when we look for constant of proportionality, we have to see if the ratios are changing at the same rate. So for every 3 I have on the top, I must have 4 on the bottom. So if I were to have 6 on the top, I must have 8 on the bottom, because this number doubled, so will this. If I have, let's say, I don't know, 30 on the top, I must have 40 at the bottom, because from here it multiplied times 10, so this one must also multiply times 10, and so on. Okay, let's do 2/5. 2/5, we can have 40 over 100. That would be, they were both multiplied by 20, right? Or we could have, for 1/3, we can have 10 over 30, or 7 over 21, or 17 over 51. All of these are 1/3. You see, 10 is 1/3 of 30, 7 is 1/3 of 21, and 17 is 1/3 of 51. As always, copy this exactly as you see it, because this is a key answer. I will be looking for this to see that you watch the video. Question 1. By how much does the cost of a dozen cupcakes increase for each bakery? Well, as it's increasing, 2 dozen, it increases by $10. See that? Here, as it increases to 2 dozen, it also increases by $10. Here, it continues on, $10 more for each dozen, and here, continues on with $10 more. Only that first dozen is $15. So our answer is it increases by $10 each. For every additional dozen, the price increases by $10. The cost from which bakery represents a proportional relationship? Proportional, which one? Well, I'm sure you can tell that cupcakes, etc. is more proportional because it's always $10. You see that? It's always $10. Here, it's not always $10. These are $10, but the first one is $15. So which one is the proportional one? Cupcakes, etc. Number 3. Graph each set of order pairs, dozens of cupcakes, total cost, on the coordinate plane. Okay, so order pairs means this. We're going to assign, for dozens of cupcakes, we'll assign this the x coordinates. These will be our x coordinates, and these will be our y coordinates. Okay, so I've pulled up the cupcakes, etc., and Mia's. And now let's zoom in here so that we can graph it. For our cupcakes, etc., we have 1 dozen, and that's going to be our x, and going up on our y coordinate we have 10. So I'm going to go right ahead and put my 10 right there. Let's make that bigger. Okay, so right there, and then 2 dozens right here. 2 dozens will be 20, and so on. 3 dozens will be 30, 4 dozens will be 40. And there we go. If I were to draw a straight line through it, it would look like this. You can see that it goes right through the origin, the 0, 0. This makes it a proportional relationship because they're moving at a constant rate, okay? Constant rate of proportionality, both directions, in both directions. It could also go up this way like this, but it has to go through the origin. Got it? Now let's graph Mia's cupcakes. For the sake of neatness, I'm going to delete this one, but please keep it on your paper, okay? And you can make it red as well. And I'm going to make Mia's cupcakes blue, but I'm going to erase this one, and I'm going to add now Mia's cupcakes. I'll take that back. I'll leave the red, so that we can actually compare at the end. So Mia, we have 1 dozen is 15. So 1 dozen is 15. It's right kind of in the middle there of the two. So it will go right there, 15. And then after that we have every 10. So then we have 25, 35, or 3 dozens. 4 dozens will be 45. And if I were to draw a straight line, it would look like this. It would go straight through, and it looks like it's proportional. It looks like it's constant, but it doesn't go to the 0 because this jump here, the initial jump, is too much, and it's not the same jump every time after that. You see, after that it's like perfect steps, right? It goes down and across at the same distance, but this one goes down too far. Okay, so yeah, it's not proportional. It has to go through the origin. Question 4. Draw a line through each set of points. What do you notice about the two graphs? Well, we just said it, right? Each graph is a straight line, but the graph for the cupcakes, etc., passes through the origin, through the 0, 0. Please copy that down. Number 5. What can you conclude about the graph of a proportional relationship? Well, we can conclude that the graph is a line that goes through the origin. What can you conclude about the graph of proportional relationship? It must go through the origin in order for it to be proportional. Okay, on the next page, we're going to identify proportional relationships. And we have these 4 graphs, A, B, C, D. Remember that it must go through the origin in order for it to be proportional. So let's look at graph A. Does it go, it has a constant change to proportionality after the first one, but the first one, see, it goes up over 1 and up 2, but here it only goes up 1. So it's not proportional. It doesn't go through the origin also, but number 2 does. Number 2 starts at 0 and it goes right through, so we can go right ahead and circle letter B. And then let's look at C. For C, we have, again, it's going through the 0, and it goes over 1, up 2, over 1, up 2, over 1, up 2, and we can continue that, and that has a constant change of proportionality, And then let's look at C, and C doesn't start at 0, it doesn't go through 0, 0. It seems to be a constant rate of change, but it doesn't go through the origin, so therefore it's not. Go ahead and circle those. Okay, analyze proportional relationships. For each proportional relationship above, A and B, right? B and C, what is the constant of proportionality? Okay, well, graph B starts at 0, and then it goes up to, it looks like it's 6, because we would have 5, 6, 7, 8, okay? And then plus another 6 would be 12, so 2 would be 12, another 6 would be 18, and then another 6 would be 24. So yeah, this looks like our constant of proportionality is 6. Therefore, graph B has a constant of proportionality of 6. And for graph C, you can see that we have a constant of proportionality of 2. For every time we move 1 over, we go up 2. You see here, we move up 1, 2, 1, 2, 1, 2, and so on. So that's our constant of proportionality. Graph C has a constant proportionality of 2. And finally, for the summary, make sure that you write that you learn about how to represent proportional relationships on a graph, how to identify proportional and non-proportional relationships, and how to identify constant of proportionality. Okay, see you in class.